Okay, ladies and gentlemen, today we are talking about ionic bonding. There's three types of bonding: ionic bonding, covalent bonding, and metallic bonding. Ionic bonding is where we're starting because I think it's easiest. But the goal of all bonding, whether it's metallic or covalent or ionic, is to get full energy levels. These noble gases over here, they are happy and satisfied, and they are the bee's knees because they have all of their energy levels full. Helium with only 2 electrons, that first energy level holds 2 electrons, so helium is happy with 2. Neon has 8, argon has 8. They all have nice full outer energy levels, and that is the goal. So when we're talking about ionic bonds, an ionic bond forms ions to bond two elements. And an ion is simply a charged atom. Particles in the atom that are charged are protons and electrons. Protons are bound up in the nucleus. Protons cannot leave because then the atomic name, the atomic identity would change, but those electrons can move around. So an ion is going to gain or lose electrons, those negatively charged particles. Now let's look at a few elements here. We have lithium. Lithium is atomic number 3. It has 2 energy levels. It has 1 valence electron. Lithium, if it got rid of 1 valence electron, it would be happy like helium because its first energy level would be full. So this is lithium. First energy level has 2. Second has 1. That 1 little valence electron there makes it unhappy. Lithium would love for that little electron to go away. If it lost 1 negative charge, that would leave it with more protons than electrons because a neutral atom has the same number of protons and electrons. So that would make it a positively charged particle. Calcium is in a similar situation, but calcium has 2 valence electrons. If it lost its 2 valence electrons, it could go back and be like argon with 8, and that's what it would like to do. So calcium would love to have these 2 little electrons fly away, and that would make it positive 2 because it'd have 2 more protons than electrons. We call positively charged particles cations. These are positively charged particles. Positive ions. Now on the other side of the periodic table, like with chlorine here, chlorine has 7 valence electrons in its 3 energy levels. If it got 1 more, it could be like argon. So chlorine would love to get 1 more. So here's chlorine and its Lewis dot diagram. It has 1 electron. It would love for a little electron to fly in. And if an electron flew in, then it would have 1 more electron than proton. And it would be negatively charged. Oxygen here, oxygen has 6 valence electrons. If it took 2 more, it would be like neon, and that would be its life's goal. It would be happy as a clam. So, I'm sorry, not, it wants to be like neon, but it's still oxygen, so I still have to write an O for it. So oxygen has 6 valence electrons. And it would love for 2 electrons to fly in and make it negative 2. These are anions. These are negative ions. Well, the only way that this is going to happen, that lithium and calcium can get rid of some and chlorine and oxygen can get some, is if they get together and bond. So when they bond, when elements bond, one gives electrons, and this is ionically bond, one gives electrons, one takes electrons. So now one is positively charged, one is negatively charged. And electrostatics keep the atoms together. Electrostatics is the attraction of opposite charges. Positive and negatives attract. So let's talk about 2 of those. Let's get lithium that wants to get rid of an electron, and chlorine, which wants to take an electron. Let's get those two guys together. So lithium has one valence electron too many, and chlorine has one valence electron not enough. So that lithium would love for its electron to go there. And then that would make it full, it would make chlorine full, it would be happy. Got rid of one, took one. Then they make a compound. And the compound that they make is lithium chloride. So when we're naming ionic compound, we take the metal's name. The metal is over here on the right of the periodic table. So we say lithium, and then we put the metal's name, the metal's on the left side, the right side of the periodic table, non-metal, and we put "ide" at the end. So here we would have lithium chloride, would be our compound name. And then we do a formula. And our formula, the formula is the metal and a subscript telling us how many metal ions we need, plus the non-metal and how many of the non-metal ions that we need. So we only need one of each, so LiCl, lithium chloride, would be the compound name for that. However, it's not always just a one-to-one, you give one, I take one. Sometimes it's more than that. Lithium wants to give one. Oxygen, where am I at? Where am I at? Right here. Okay. Lithium wants to give one. Oxygen wants two. But they can still bond and be friends and be happy. So here's our lithium with its one extra electron. And here is oxygen with its 6 electrons. I'm not drawing this to the best of its advantage here, but that's all right. Actually, I'm going to switch it. I'm going to put these two over here. So this right there, that electron would come in and fill in that oxygen quite nicely. But one is not enough. There needs to be 2 lithium so that oxygen can get 2. So now our name here, our metal is lithium, our non-metal is oxygen. So this is lithium oxide. And the metal is lithium. It takes 2 lithium, so it's Li2O. It's only 1 oxygen, lithium oxide. When you come to class tomorrow, you're going to get a sheet like this. It has a whole bunch of elements that you're going to be working with, separating into gain and lose electrons, getting oxidation numbers. I didn't say what oxidation numbers were. I'll have to do that. Circling metals, highlighting non-metals, and then making up 10 possible ionic compounds using Lewis dot diagrams for each, writing the chemical name and formula. So the oxidation number, let's go back to the oxidation number. Let's look here, this is in the front page. +1 is an oxidation number. +2 is an oxidation number. -1, -2. So that right there is the oxidation number. How many electrons does it want to gain or lose? Okay, this one was a long one, lots of content. Come to class, we're ready to go. Have a good night.